Here's a video for the rest of 3.3 with the inequalities. Okay, we did the equalities where they're equal. We're going to solve inequalities. So kind of thinking about this graph here, thinking back to chapter, I think it was 2 we did this. Where is p of x equal to 0? Okay, so where are my outputs 0? So if you think about this point right here, this would be a point 2, 0. And this point here would be the point negative 3, 0. So I know my output, my y's are 0 when x is equal to negative 3 and 2. Those are our solutions, okay, where it's equal to 0. Now, where are my outputs going to be less than 0? So all this area right here, the outputs are negative, okay? So it's going to be between negative 3 and 2, if we use interval notation, between negative 3 and 2, it's going to be less than 0. Where's p of x greater than 0? Okay, here, right, these are positive outputs, and here, these are positive outputs. So from negative infinity to negative 3, and also from 2 through infinity. Okay, that's where we have positive outputs. Okay, next one here. Where is it equal to 0? Try and pause this and do it yourself. Okay, where is it equal to 0? Okay, it's equal to 0 here at negative 1 and 4. Where is it less than 0? Okay, less than 0, negative 1, negative 2, negative 3, right? These here will be less than 0. So we're looking at what x is true. So from negative infinity to negative 1. And remember, if it would be or equal to, use the bracket, okay? And also from 4 through infinity. Where is it greater than 0? Okay, greater than 0, these numbers would be greater than 0. 1, 2, 3, 4, 5, okay? So between here and here would be greater than 0. So between negative 1 and 4 is where it's greater than 0. Okay, same graph here. We're going to answer the same questions, I just didn't write them out. Where is it equal to 0? It's equal to 0 at x equals 5. Where is it less than 0? Okay, it doesn't ever go less than 0. So it's never less than 0. And C, where is it greater than 0? It's greater from 0 from negative infinity to 5, and then also from 5 through infinity. But at 5, it's 0, right? So now if I said, where is it going to be greater than or equal to 0, then it would be all real numbers, okay? But just it's not equal to in this problem here. Okay, this one here, where is this equal to 0? It's not equal to 0 anywhere. It doesn't come down here and hit 0. Where is it less than 0? Nope, it doesn't come down here to be less than 0. Where is it greater than 0? Okay, it's all of my out everywhere it goes, it's always going to be greater than 0. So between negative infinity and positive infinity, right? For all these x values, from negative infinity to positive infinity, it's always positive, the output. Okay, so how do we do this without the graph? Okay, well, we want to solve it. Let's pretend it's equal to 0. So if factoring, I always like factoring. It's an easy way to do it. X minus 4 and x plus 3. And if I solve this, I get x equals 4 and x equals negative 3. Okay. So by looking at this, if you think about the graphs we just did, I know it's going to be equal at negative 3 and at 4. Now, I also know that since this is positive, I know it's going to open up. So I know it's going to open up. Okay, and it's going to have to go through those 2 points at 0. Okay, I don't know any other points, but I know these two. So I know we want to know where is it less than 0. So here it's going to be greater than 0, less than 0, greater than 0, right? So it's less than 0 between negative 3 and 4. Okay, if we solve the next one, if we factor 2x and x, to give you plus 3 would be 6, plus 1 would be 7, right? 6 plus 1 is 7. And we get x equals negative 1/2 and negative 3. Okay? So thinking about, we know at negative 3 and negative 1/2, you know the parabola is going to go through there. Once again, since it's a positive, we know it's going to open up. Okay? So we want to know, where is it greater than 0? Okay, so it's going to be greater here, and it's going to be greater here. So from negative infinity to negative 3, and also from negative 2 through infinity. Okay. This one here, we want to get it equal to 0 first before we start. So 2x squared plus 5x minus 12 greater than or equal to 0. Okay, if we factor 2x and x, plus 4 minus 3 would be 8 minus 3 is 5. Set them equal to 0, you get 3/2 and negative 4. Okay, so thinking about a graph, I know it goes through here at negative 4 and also here at 1 1/2 at 3/2. Once again, it's positive, so you know it's going to open up. So we want to know, where is it greater than 0? So it's equal to 0 here, greater than 0 is here and here. So from negative infinity to negative 4, and from 3/2 to infinity. Okay, next one, number 8. Try these yourself. Try and do it yourself if you can. Okay, this one here, x minus 5 and x plus 4. So x equals 5 and x equals negative 4. So at negative 4 and 5, and once again it's positive. I should have given you some negative ones here. But it's positive, so the graph looks like this. Where is it less than 0? Down here, right? So between here and here is net less than 0. So between negative 4 and 5. Okay, now this one won't factor. Nothing will multiply to give you 2 and it had to be negative 4. So we're going to have to use another method. So you can either use completing the square or the quadratic formula, whichever you prefer. I'm going to use completing the square. Okay, so I'm going to take that. I'm going to pretend it's equal to just to solve it. Okay, so subtract the 2 over. Half of negative 4 is negative 2. Negative 2 squared is 4. So to complete the square, so this will be x minus 2 squared is equal to 2. Square root both sides. Don't forget that square plus or minus. That's easily forgotten. And add the 2 over. So 2 plus or minus the square root of 2. Now, I don't know exactly. You could figure them out what those numbers are. I'll do it here. So 2 plus the square root of 2 gives you 3.4 something. And 2 minus the square root of 2 gives you 0.58, 0.59. So 2 minus the square root of 2 would be there. And once again, it opens up. So it looks something like this, opens up. So where is it going to be greater than or equal to 0? Right here and right here have outputs that are greater than or equal to 0. So we have it from negative infinity to 2 minus the square root of 2. And then from 2 square root of 2, 2 plus the square root of 2, all the way out through infinity. Okay, this one here, we have the square method. So we can use the square root if we add 9 to both sides. I have x squared is greater than 0. Square root both sides, I get x is greater than plus or minus 0. Okay, so we have 0 as kind of our point there. It's opening up, so we only have one answer, so it's going to look like this. So where is it greater than 0? It's going to be greater here and greater here. So from negative infinity to 0, and from 0 to infinity. Okay, so there's your inequalities. I'll throw these in here too. Say we want to solve for d. Okay, notice it's squared here, right? So let's solve for d. So we can multiply both sides by 4. We can divide the pi over. And then we can take the square root. Okay, so we can solve for those things too. This one's a little more complicated. Notice we can't do that because we're solving for the t, so we got t here and we got t here, right? We could only do this here with the square root method. So here you're going to have to either use the quadratic formula completing the square. I'm going to use the quadratic formula. So we got some number t squared minus some number t minus your k equal to 0. So when I plug this into the formula, I have negative the b plus or minus the b squared minus 4 times your a times your c divided by 2 times your a. Okay, and this would be s plus or minus the square root of s squared. Two negatives make it positive 4rk over 2r. And we can just leave it like that because we don't really know what all the things are. Okay. This one, just a little bit of practice here too. We can multiply both. Take rid of 4/3. We can multiply by 3/4, the reciprocal. So we have 3v over 4. And that 4 over 4 and 3 over 3 cancels. So we have pi r cubed. Divide by the pi. So we divide by pi there. And we can take the cubed root. When you have that, we haven't really talked about that this year yet, but you did in Algebra 2. We can take the cubed root of this to have r by itself then, and you're done. Okay.